Right, so let's finish up the task of that. So we have, first of all, with our warm-up today, the same thing as yesterday's with the arc length and what's going on. I'm going to just put answers on here really quickly. So go ahead and pause, do your work, and the answers will be here in just a moment. All right, so for our first one, we have 14 pi divided by 3 meters, which is, if you 4.667 pi. I like my answers in terms of pi. It says so right here, so make sure pi is in your answers. 7 pi millimeters and 3/2 pi inches. So those are our answers to the warm-up. Let's move on. And so now we had our stakes we were trying to figure out, and full answers are right here. And so that 10 radical 3 thing, that's me just going a little bit further into that. So we had 10.3 repeating, but we also know that the sign of that the cosine is the square root of 3 over 2. And so that's where we get 6 radical 3 and 9 radical 3. It's a lot easier to keep these answers here. These are the answers to yesterday's video. So Javier also has another suggestion of what they can do. So this is what our task is today. That we can to record the location of each stake and its distance around the circle for the set of stakes. It might also be interesting to record the arc length, the radius for each circle. So we've got the same. So all the points we've already found, all of those. So you can just take all your points and transfer them to the list. So, and then we want to figure out how far away we are from, so basically your arc length, this is arc length, how far away we are from the stake at each point, and then the ratio of arc length to the length of the radius. So, stealing from our answers that we got yesterday, we're going to use the 6 radical 3 and 6. So 6 square roots of 3, comma 6. And the decimal point is fine, but exact answers are always a little bit better than decimal points. So that's our answer there. And now we want to figure out what our arc length is. And again, we're going to be using all of the warm-up stuff we've been doing to kind of figure that out. Another way we can do that instead of using proportions is actually if you take the fraction that's created by the angle divided by the circumference divided by the whole circle, you can just times that by the circumference. So the circumference of this circle for the first one with 12 is 24 pi. So we're dealing with 24 pi as our circumference for this one. And then for over here, when we get to this one, it'll be 36 pi. That will be our circumference. So we'll need that. I'm going to be doing most of my examples here on the first chart. And we'll see what we've got going on here. So 24 pi. And we've got 30 degrees as our stake number 2. It's 30 degrees. And then 60 degrees. 90 degrees, 120, 150, 180, 210, 240, 270, 300, and 330. So those are the angles we're going to be using. And we're going to be doing basically fractions of pi. So 24 pi times 30 divided by 360. So 30 divided by 360 as a fraction is 1/12, which makes sense because we cut our circle into 12 pieces. So we've got 1/12 of 24 pi is 2 pi. And so that is our distance around the circular path. And so for the next one, it'll be 2/12 or 1/6, and so on. So what we ended up with here is 30 over 360 was equal to 1/12, and we times that by the circumference, which is pretty cool and nice because it'll always work, and we love things that always work. It's always nice when things work. We take it for what it is. And so you're going to be filling out your charts. The next one is going to be 4 pi, then 6 pi. Notice that we're counting by 2 pi's as we go. And again, these numbers are going to come from off the answers I gave you at the beginning of the video. And so you can steal from there if you want. Or certainly you can steal your work from yesterday, but it's nice to have things that are compact. So, and then this is the part that's weird, is the ratio of the arc length to the radius. So what we're going to do is take the arc length that we found, 2 pi, and divide it by the radius, which in this case is 12, which ends up being equal to pi 6 for this problem. And so for the next one, it'll be 4 pi divided by 12, which is pi over 3. And then it's going to be 6 pi divided by 12, which is pi over 2. So I'm going to stop here, and you need to pause the video and again try to figure these out. This is your basic task for the day. Try to fill in these 2 charts. So I've given you some hints for the first 3. We're also going to be stealing our numbers for the ordered pairs. And so go ahead and take them from the chart and fill everything in. And then once you're done with the 12, you can move on to the 18, or you can do them at the same time. Go ahead and see what you can come up with. Okay, so I finished the 2 charts. I did not go ahead and write down all the points from the other picture. Figured I'd already given you that information. I didn't want to write it down again. And so what I noticed right here is we're counting by 2 pi's as we go down this chart. Turns out over here we end up counting by 3 pi's. But what is the coolest thing that I noticed is that the ratio of arc length to radius is exactly the same. And so question 5 asks us to summarize some of the interesting things we notice. So those are the 2 that I noticed, is the patterns in the arc lengths, and then that the 2 ratios match. I'm going to come back here. You need to come up with some more. You need to come up with at least, there's a lot of things to notice. You can notice something about the way the ordered pairs behave. What the connection I want you to remember that we're trying to draw is, I don't know if you recall the definition of a radian measure, but a radian measure is the ratio of arc length to radius. So this is radians. And so if you compare, 30 degrees is pi 6, 60 degrees is pi thirds, 90 is pi halves. So that's something to notice. It's important. That's pretty much the important takeaway from this section of our notebook. So we'll talk more later, and good luck to you.